Hello all. Welcome to my tech channel where we cover the latest gadgets, software, cybersecurity and more. Whether you are a tech enthusiast or just looking to stay up to date, this channel is for you. Join us as we explore the exciting world of technology. Thank you.
Hello all, welcome to Linux Shell video. This video is part of our Linux series where we talked about Linux and the concepts or the terminologies related to the Linux. This video is mostly concentrated on Shell, but before starting on Shell, I would like to explain about the Linux terminal, Shell and CLI and the interconnection between these three concepts. So first understand the Linux terminal. Linux terminal is the application that provides a user interface for interacting with the CLI, and CLI is the environment where you can enter commands to interact with the operating system. Think of it this way: the terminal is like the window or doorway and the CLI is the room you enter. The shell, on the other hand, is the program that interprets and executes the commands you enter in CLI. In simple terms, the terminal is the program you use to access the CLI, while the shell is the program that interprets and executes your commands within CLI. So basically, when you type a ls command, to type that command you use terminal, and through terminal you basically try to access CLI, and when you enter the command, it's a shell who understands that command, interprets that command, share that command with the operating system and get the output and show you that text-based output through CLI. So that's the connection between these three concepts. So understanding this distinction will help you navigate and leverage the power of Linux command line environment more effectively. So let's start about Shell. Shell, in the context of computing, is a user interface that allows you to access various services of an operating system. A shell can be either command line based or a graphical user interface. So next part in this video is how the shell works. So basically, like, we need to first understand when you type a command in terminal, what happens, how shell use that command, execute that command and get the output. So for this example, I'll be using the command ls-l. So let's break down the process of how Linux shell works using an example command such as ls-l, which is used to list directory contents in a long format. Step 1 is command input. You start by typing command ls-l in the terminal and press enter. The terminal sends the text of the command to the shell. So right now ls-l is just in the text format. It's basically a command but it's in a text format. In second stage, the command interpretation happens where the shell reads the command from left to right. So basically it first identifies ls as the command to be executed, and then -l is identified as an option to the ls command that modifies its behavior to display the directory contents in a long format. In third stage, the command execution happens where the shell then searches for the ls program in the system directories, and this order in which the searches happen is based on the path environment variable. Once it finds the ls program, it creates a new process and the ls program is loaded into the new process. In fourth stage, option implementation happen where the ls program then interprets the -l option and executes the command accordingly, gathering the information to be displayed and all. In fifth stage, the output display happens where the ls program sends the output back to the shell, which then displays it in the terminal. This output is detailed list of directory contents. The sixth and the last stage is return control. So after command has been executed and the output displayed, the shell returns a prompt to the user indicating that it is ready to accept the next command. This is a simplified explanation what happens under the hood. There are more complex operations that can occur, especially when executing more complex command and script. But this gives you a basic understanding of how Linux shell works. So in the next section, we'll talk about the different types of shells, the shell uses in Linux-like environment, and then the difference between bash and ZSH, and some of the shell related technologies which we'll explore further in this video. So first talk about the types of shells. There are multiple types of shell in Linux such as Bourne shell, sh, then C shell, csh, corn shell, ksh, born again shell which is bash, and then z shell which is zsh. In this video we'll be looking in more depth into bash and zsh shell only. So now let's talk about bash versus zsh. These both are most popular shells in Unix like system. They have a lot of common, but there are some key differences. So let's talk about the syntax differences. In terms of syntax, bash and zsh are quite similar because zsh syntax is a superset of the bash syntax. This means that any script written in bash can run in zsh. However, zsh has some additional features and options that aren't available in bash, those such as like interactive features. zsh has many features that improve its interactivity. These include like spelling correction, CD automation, and better auto completion. Bash also has auto completion, but it's not as powerful or flexible as zsh. Then there comes customizability. ZS is highly customizable. You can change its prompt and behavior in many ways using the .zshrc configuration file. Bash is also customizable, but not to the same extent as ZSH. Then there is a scripting features. ZSH has some advanced scripting features that aren't available in bash. For example, ZSH supports floating point arithmetic while bash does not. Then there is a programming language difference, then command difference, which will try to explore some differences between bash and zsh, how they are different to each other, and then we'll deep dive into the shell related technologies in more detail. So now let's talk about some shell related terminologies or technologies you might have heard in bash or zsh. So these terminologies are shell initialization files, path, environment variables, and aliases. So these are like some of the terminologies which relate to some configuration files that shell reads when it starts, or some path variables it needs to load the binaries, or some aliases which can be useful to reduce burden of memorizing some of the big command and then having some shortcuts. So we'll look into in more depth about this terminology with some hands-on session, so be ready for it. First concept is shell initialization files .bashrc, .bash_profile, or zshrc or z-profile. These are scripts that run at the start of the shell session. They are used to customize the shell environment. For example, you might set environment variables, define aliases, or change the command prompt in these files. So first let's look into the bash. So if I type here ls-a, you'll find there are two files, bash profile and bash rc. These are like example files. These are not actually configuration file for this specific container where I'm running my bash shell. And the next container you can see here, I'm running the zsh shell. So I'll show you side by side the difference between these two files and how this two shell works. So first let's talk about bash and the first file, bash profile. So if I type here, if I look into the bash profile, you can see there are some code where it like get the aliases function, run user specific environment, or start a program. So in short, bash profile basically sets environment variables that should apply to user. For example, it might add additional directories to the part environment variable. Second, it starts program that should run when the user logs in. For example, it might start a mail client or a newsreader. Third, it sources the bash rc file to incorporate the configuration there into the login shell. We'll talk into about the login shell and all. And for bash rc, you might be wondering like what's the rc. For that, check out the comment. You'll find some fun thing about the rc. So next file is bash rc. Let's go into the bash rc. I will type here dot bash rc, and you can see that it's basically get used for set aliases, which are like shortcuts for longer commands. We'll talk into more on that. Then second is define functions, which are small scripts that run and can be run just like a command. Third is it sets a shell options. For example, it might set -o vi option to enable vi style command line editing. Fourth is it can be used for modifies the shell prompt by setting ps1 environment variable. Here in last section you can see this ps1 environment variable is get used for changing the prompt. So this is bash rc and bash profile. So let's talk about, or let's see into the ZSH. So right now I'm in my ZSH shell. If I type here ls-a, you can see there are two files, z profile and ZSH RC. So this ZSH RC or bash RC or bash profile, Z profile, both are almost same. There is not much difference between them. Functionality wise, they perform the same function. So in case of ZSH RC, if I go to ZSH RC, you can see like the content is almost same. It's also get used or it's specific like ZSH specific options using like set out, set opt and unset opt commands. It can be used for defining ZSS specific functions and aliases, or it can be used for modifying the shell prompt by setting the prompt variable. And when you go into the ZSS Z profile, sorry, Z profile, oh shit, I have created a new file. Sorry, not Z profile. Okay. So in Z profile, you can see like it can be used for executing the commands at login similar to that bash profile, and typically sources ZSH RC to include those configuration into login shells. So more or less this command or sorry, this configuration files are same, be it bash or ZSH. Now let's talk about path. The path is an environment variable on Unix-like operating system for specifying a set of directories where executable programs are located. In general, each executing process or user session has its own path setting, which is a colon delimited list of directory paths. When you type a command in the terminal, the system uses path variable to determine where to look for executable file corresponding to that command. Here is an example of what a path variable might look like. In this example, the system would look for executable files in the following directories in order: usr local sbin, usr local bin, usr sbin, usr bin, spin, and then lastly bin. So when you type a command, the system looks in each of these directories in order. As soon as it finds an executable file with the correct name, it stops and runs the file. Current path in a shell session with command echo $path, and here you can see that currently this shell session path variable consists of these values: user local bin, and spin and all that stuff. And also, if you want to add a new path to this path variable, you can add this command export path is equal to new directory. So let's say I'm adding home, then colon $path. So I'm basically what I'm doing here, I'm adding my this new directory /home to the front of the path, so that next time whenever I'm typing any command, my system will first look into this directory. So let's check echo path. Now you can see /home, the new directory has been added in the front of the path. So next time if I'm typing ls or anything, any command, the shell first will go to this directory, search for that specific command or the binary. If it is not available, then it will go to the next path in the path variable. Let's talk about environment variables. Environment variables are name string that can be used to configure the way programs run on your computer. They are part of the environment in which a process runs and are passed from the shell to the program it runs. They can be created, edited, saved, and deleted, and they give users a way to manipulate the behavior of a running program. There are some key points related to the environment variable, such as global versus local environment variable, how to set local or global environment variables, how to access those variables, what is common variables or persistent or inheritance in the context of environment variable. All this concept we'll be exploring here in this video. So let's first talk about global versus local. So environment variables can be global or local. Global variables are also known as system environment variables. So they are typically available to all processes in the system. They are typically set in system-wide configuration files that can read when the system starts up. So for example, etc/environment or etc/profile in a Unix-like system. So changes to these variables will affect all users and processes on the system. Examples of global environment variables include PATH, which is path, HOME, home, and then USER, user. In the context of local environment variable, these environment variables that are only available to a specific process or a shell session. They are typically set in shell itself, either manually or in a shell specific configuration file like .bashrc or .zshrc. Changes to these variables only affect the current shell session and any processes started from that session. If you start a new shell session, it will not have access to local environment variables set in a different session. So it's basically global is applicable, or if you set something globally, it's accessible over all the process system. Whereas in the local, if you set something, it will be available in that specific shell session. So that's the difference. Global versus local environment setting in Linux shell. So here you can see right now I have two tabs open in my terminal. First one is for global and the second one is for local. So if I go here in my global, and as I mentioned earlier, if you want to set a variable as a global, you need to edit /etc environment or profile. So I'll be setting up the value in profile. Here you can see on the last line of this file, I have set up the variable name global var with the value I am global variable. So I'll just go back here and I will try to show that variable. So let's try echo $global underscore var, and you can see the value is showing here I am global variable. So that's how you can set the global environment variable, by going or by adding the export global variable, or in my case is global var is equal to the value. So you can say add that value in etc environment or etc profile, and that global variable will be available to all the system processes. However, in the context of local, if I set, for example, here I am setting out now a local variable named as local underscore var. So I am setting it up by adding export space local var. I am local value here. So if I ask my shell to show me the value of this variable local underscore var, you can see it's available here. But if I try the same value in another session of my same systems, another tab or another cell session, it won't work there, because this local environment variable value is only available in this local shell session, and in another shell session it won't be available. However, in the case of global, it will be available to all system processes in all the shell session. Let's look into the alias, the next concept in shell related terminologies. Aliases in Unix or Unix-like operating system are a way for users to customize their environment. They allow users to define their own commands by substituting a string for the first word of a simple command. They are often used for commands that are long or frequently used. So in simple terms, aliases means like you are creating a shortcut for a long command, and going forward from there you will use that short form to execute that specific command. So let's have a look on how to create an alias and how to use that. So for example, here if I type ls-l, I'll get a listing of the content of the specific directory, but I do not want to type every time ls-l. So what I'll do, I will create an alias for ls-l. So you can create an alias using the keyword called alias, or the command, you can select command. So I'll type alias ll is equal to single quote or double quote, whatever is your like, and then enter. So right now what happened, the system created, right now the shell is creating alias for ls-l with the name ll. So right now this ll shortcut is for ls-l. So if I type ll here, I'll get the same output. So that's the alias for you. And now whenever you type ll, the shell will substitute ls-l in the backend. So how you can use an alias? An alias can be used by just typing the short form you created. So in this case, LL. And now you can use the alias. You can even list out the alias by typing alias. If I type, you can see what are the already been created alias. So for egrep, this is the alias created, and you can see the second last one, LL is equal to ls space hyphen L. So if you type just alias, you can list down the alias created by the shell. In the current shell, what are the alias are available. You can remove an alias by typing un al as and ll, and if you type that, and again if you type alias, you will find that the ll alias we created is now unlisted. So you can unlist or basically like remove the alias from the system or the shell as well. So that's the alias. I hope it helped you in understanding the shell related concept. Going forward, the next section will talk about the uses of the shell. Shell uses. So in this section, we'll understand the uses of bash or ZSH as a different types of shell or different types of uses as a shell. So basically, you know, bash and ZSH, these are basically a shell programs, while the terms login shell, interactive shell, etc. are referred to those shell programs are being used. So given some example is, you can use shell for as a login shell, interactive shell, non-login shell, non-interactive shell, and subshell. So let's talk about first the login shell. A login shell is the first process that executes under your user ID when you log in for an interactive session. The login shell reads configuration files for the shell environment. In the case of bash, it reads etc profile, a global configuration script that applies to all users. Then it reads the first file it finds among .bash_profile, bash login, and .profile, whichever comes first in that order. These are personal configuration scripts that individual users can modify to their preferences. The hyphen as the first character of a shell processes, visible in PS command output, indicates a login shell. Interactive shell is connected to a terminal and can accept commands from the user. Both login shell and non-login shell can be interactive. Interactive shells read the file /.bashrc for bash and .zshrc for zsh. To configure the shell session, this file is often used to set shell options, define functions, and configure aliases. Third is non-interactive shell. Non-interactive shells typically execute scripts and do not interact with user via a terminal. They do not read the bashrc or zshrc file. When a shell script is executed, it runs in a non-interactive shell. The environment is inherited from the parent shell, but changes in the script do not affect the parent shell's environment. So in simple terms, when you run a shell script, it basically runs as a non-interactive shell and not the interactive shell. The fourth one is non-login shell. A non-login shell is typically a shell session that you start manually after logging in, like opening a terminal window in a graphical desktop environment. Non-login shells read the configuration file bashrc and zshrc in the case of ZSH. They inherit the environment from the login shell from which the desktop environment was started. So it's basically when you logged in into your system and when you start the manually any terminal, that time the non-login shell gets used. The fifth and the last uses of shell is subshell. A subshell is a child process launched by a shell or shell script. A subshell is created when a command or pipeline is enclosed in parentheses. Subshells can be also created by shell control structures, shell script, or when a shell is backgrounded. Subshells inherit the environment such as variables, functions, options from the parent shell, but changes in subshell do not affect the parent shell. Each of these shell types has specific behaviors and uses, particularly in how they read configuration files and interact with user or system. They are fundamental to flexible and powerful nature of Unix-like operating system. Thank you for watching this video. If you like my videos, please subscribe to my channel, like and share with your family or your friends. Thank you.